Hopper from Archimeters. Archimeters is a decentralized parametric design platform. We explore new possibilities for NFTs by giving them the ability to be actually manufactured in real world. The process of minting identity NFTs and publishing designs has been shown in our previous demo video, so I will skip that part and focus on how we print generated NFTs into real physical objects. So now let me connect to the wallet first. Okay. And let's say gallery. When an atelier here loads, it downloads algorithm files from Walrus and reconstructs them on the page. As you can see, design series can be very simple, like a cube where you can adjust the size, or a more complex one, like this, the artwork that uses genetic algorithms and multiple parameters. And it looks pretty unpredictable, right? Cool. Besides, they can also be practical objects like this series that can work as a vase, a cup, or a pen holder. It's up to you. We want to make sure that designers control their style while users get objects that match their needs rather than relying purely on luck. And now let's look at the vault, where you can check your asset here. The first tab shows ateliers, which represent design series. If you own an atelier cap, you can claim revenue from your design series here. I will just show once, like this, and it refresh. The other tab shows all scopes. These are owned objects generated from ateliers. Okay, here. From this tab, you can send print requests to other people's printers. Now they are offline. To demonstrate this entire workflow integrating Sui and Walrus, I would like to introduce Eureka. It's a TUI app we developed using the Sui Rust SDK. This app bridges local manufacturing equipment with the Sui blockchain. When running, it checks if the current device's active address owns a printer object. If not, it requires user registration. Let me show you the registration video first. Input the printer name here and press enter, and it's all done. Now let me show you Eureka on my computer. Yeah, and by default it's in offline mode where users can only print their own scopes. You can see here and here. Once again, it's the same since they are the same address. Let me copy this ID and head to Explore. Yeah, the print. And please notice that the status here is online status is false, and when I switch to online mode, it will change the printer status. I'll just press toggle status and confirm, and this should work. Let me refresh. Now it's true, and we can get back to here, and yeah, you can see the printer is online now, and we can send and print job to this printer. I'll just select it and print sculpt, approve, and let's back it here. The printer checks for print jobs. When it finds one here, the owner can see the print job on the TUI app and press P to download the STL file from Walrus and start printing. It triggers on-chain transactions to update the print job status and transfer the completed print job to the corresponding sculpt when the printing process finishes. This creates a traceable record of when and which machine created each physical object. Since I don't have a real printer connected now, let me show you a video of the actual printing process. Yeah. This is using HDMI output from the Raspberry Pi, which can also be remotely controlled via SSH. Okay, so we've implemented the basic flow from algorithm to physical object. Future development might move toward to architectural scale applications. This is from Russell. Thanks to Professor Shen Yuting from our school's Russell Lab for assistance.